So under normal circumstances, I would say that that sound was music. But for the purpose of this video, I'm going to say that that sound was physics. And I say this because in chapter 16, we discussed standing waves. And standing waves are waves that are trapped between two nodes or two boundaries. And what happens is the waves reflect off of the boundaries and then they constructively interfere. And I feel like an excellent example of standing waves is the guitar. And before I go any further, I'm just going to briefly introduce the parts of the guitar. So up here, you have the head of the guitar where you have the tuning pegs. Right here, you have the nut of the guitar. You have the strings, and then you have the fretboard. And then these little squares are frets. This up here, this whole thing is called the body of the guitar. And then you have the bridge of the guitar. And then you have the saddle. And you also have the sound hole of the guitar. And I have an acoustic electric guitar, so I have an electric tuner. And down here, I can attach a 1/4 inch to project the sound to an amplifier. And so the theory of the guitar is you pluck a string, the string vibrates, and then it causes the bridge to vibrate, and then that causes the saddle to vibrate. And when the saddle vibrates, it causes the soundboard inside of the guitar to vibrate. And when the soundboard vibrates, it moves the air that's inside of the guitar and it pushes the air along with those vibrations out of the sound hole, and that is the music that you hear. And the pitch or the note of the music that you hear can be affected by a few things. So from the nut to the saddle of the guitar, you have the overall length of the strings. And if you notice, as I move further away from the nut, I'm decreasing the length of the string, and that causes the frequency to increase, and that is why we hear a higher pitch. And that's one way that you can affect the pitch of the sound that you hear. Another way is by increasing or decreasing the tension of the string. So if you notice, as I increase the tension, you hear a higher pitch, and as I decrease the tension, you hear a lower pitch. And this is because tension and the velocity or the speed of the wave have a square root relationship. And so as you increase the tension, you increase the velocity of the wave. And velocity and frequency has a direct relationship. So as you increase velocity, you also increase the frequency of the wave. And this is why you hear a high pitch. Another way you can affect the pitch is by changing the material of the strings on the guitar. So each string has a different linear mass density, and linear mass density is the mass of the string divided by the length of the string. And so the velocity of the wave and linear mass density have an inverse square root relationship. And so if you have a higher linear mass density, you have a lower velocity. And velocity and frequency are directly related. And so a lower velocity means a lower frequency, which means a lower pitch. And I'm not sure what the material of my strings are, but you can see here that this low E string is thicker than this high E string, which is why the pitch is lower for this one and higher for this one. And those are 3 ways that I was able to apply what we learned in chapter 16 to my guitar.